Hi dear students, so welcome back. We will be continuing motion in one dimension today. So till last class what we have studied? We have studied about distance displacement. Displacement is the shortest straight line path from initial point to final point. Distance is any path. Displacement is also a distance. Then the difference between speed and velocity. Speed is distance by time and velocity is displacement by time. Speed, distance, they are scalars. Velocity, displacement, they are vectors. They have a particular direction too. Then velocity v is equal to, the formula can be v is equal to displacement by time or change in position by the time duration. This can be written like this also, if this t is taken as time duration. Then what? Initial position minus final position minus initial position divided by final time minus initial time. Everything is fine, any formula of our choice. Okay, so this is the formula for velocity. Then we studied about average velocity, then average speed. So this is nothing but sum of displacements divided by sum of time, or s1 plus s2 plus up to sn divided by t1 plus t2 up to tn. This is a general formula. If we get same distance or displacement interval, then V average can be 2v1 v2 divided by v1 plus v2. If three distance intervals are given, 3v1 v2 v3 divided by v1 v2 plus v2 v3 plus v1 v3. If two time intervals are given, same time interval, then we have v average is equal to v1 plus v2 by 2. All these shortcut formulas, we have done enough number of problems also for all these areas. So today we are moving into acceleration, our fifth term, fifth concept, fifth terminology, that is the very much basic of this motion in one dimension. So that we will start today. Okay, so distance, displacement, speed, velocity, and finally acceleration. So this is what we will be studying today. All these are completed. Okay, you know what every term is. Now we will study acceleration. So acceleration is very simple. You know, if you are driving a vehicle, if you are driving scooty or bike, right side, if you can apply accelerator just by moving the handle. Just like in the handle itself there will be a lever which will be moving. If you apply that, your speed will increase. So acceleration is nothing but rate of change of speed or rate of change of velocity. Okay, actually precisely speaking, acceleration is nothing but rate of change of velocity. Okay, say for example we will take a scenario like at a time, this is time, this is velocity. Say at 9 o'clock, 0 minutes 0 seconds. Suppose if the velocity is 5 meter per second. and again at 9 o'clock 0 minutes 1 second, exactly after 1 second, if the velocity is again 5 meter per second, at 9 o'clock 02 again velocity is 5 meter per second. So these kind of motion already we have seen, that is called constant velocity, uniform motion, or this address constant velocity. So here no change in velocity, so the value of acceleration is 0, and all these problems we did with this equation, or delta x by delta t. Now consider this situation at 9 o'clock 0 minutes 0 seconds. If the velocity is 5 meter per second, 9 o'clock 0 minutes 1 second, if the velocity is 10 meter per second, at 9 o'clock 0 minutes 2 seconds, if the velocity is 15 meter per second, and at 9 o'clock 0 minutes 3 seconds, if the velocity is 20 meter per second. Now you can observe the velocity is increasing 5, 10, 15, 20. 5, 10, 15, 20. Now here there is acceleration, there is change in velocity, increase in velocity is there, so that the acceleration is there. So how to find acceleration? Acceleration is rate of change of velocity, So it is very simple. A is equal to V2 minus V1 by T2 minus T1. Just like velocity is rate of change of position, okay, rate of change of position or rate of change of displacement. Change in position is what? Displacement. So rate of change of position is same as rate of change of displacement. That is what velocity. Same way acceleration is nothing but rate of change of velocity. So A is equal to V2 minus V1 by T2 minus T1. Clear? So we will see here. So now this part I am taking constant velocity, we don't need it, okay. So see, the data are connected like this. For time, for this time this velocity, for this time this velocity, likewise. So what is the acceleration between these two segments? Okay, A1 will consider. So V2 minus V1 by T2 minus T1. So what is V2? 10. What is V1? 5. What is T2? I can simply take 1 second. Now all the way I need not write all that changes. So this minus this, directly I am writing 1. So this is nothing but 5 meter per second square, because already this is, its unit is meter per second, its unit is second. So 5 meter per second square. Now we will consider this one. So here this is again V2 minus V1 by T2 minus T1. 15 minus 10, 15 minus 10 divided by this minus this. So 15 minus 10 divided by 1, 2 minus 1. Again what? 5 meter per second square. So we will take this is nothing but 20 minus 15, 20 minus 15 divided by 3 minus 2, 1. Again I get 5 meter per second square. So the value of acceleration is constant here. If you want, you can take from this to that. 5 meter per second, 20 meter per second. We will find that also. A is equal to 20 minus 5 divided by this time minus this time. So 9 hours 0 minutes 3 seconds minus 9 hours 0 minutes 0 seconds. The difference is nothing but 3. So this is 15 by 3 is equal to 5 meter per second square. Okay, so here we are getting constant acceleration. Acceleration is not changing, acceleration is constant. Suppose if you are using bike, if you apply accelerator, the speed is increasing, the velocity is increasing, and you are not ready to change. You keep your hands like this, and if you keep applying accelerator like this, so the velocity keeps on increasing. Okay, so constant acceleration, but velocity will be increasing. Pause the screen, note it down. Okay, so this is constant acceleration. We will see uniform acceleration or constant acceleration. We will see non-uniform acceleration also. So we have 5 meter per second, then we have 10 meter per second after 1 second, then we have 0, then we have 20 meter per second. So this is the velocities v1, v2, v3, v4. If we take a1, v2 minus v1 divided by t2 minus t1, so this is going to be 5 meter per second square. So in this time interval, this is the acceleration. A2, 0 minus 10, final minus initial, v2 minus v1. A is v2 minus v1 by t. T is time duration. I can put delta t, any whatever you want you can write. Only thing is concept or the application must be correct, that's it. So 0 minus 10 divided by again 1. So what we are getting, minus 10 meter per second square. What this negative indicates, actually acceleration is negative there. What happens there is deceleration. So when you apply brake, your velocity will come down. So velocity will be reduced. Okay, so acceleration can be positive, acceleration can be negative. Acceleration is positive means velocity will be increasing. Acceleration is negative, velocity will be decreasing. So for acceleration negative means we call deceleration or retardation, whatever it may be. Okay, then A3, 20 minus 0 by 1. So this is 20 meter per second square. You can see acceleration values are 5 meter per second square, minus 10 meter per second square, then 20 meter per second square. All the values are different. So this is not uniform acceleration, this is non-uniform acceleration. This is an example of non-uniform acceleration. Non-uniform acceleration. Clear or what? Okay, pause the screen, not all the data. Okay, so in our practical case, when we drive a vehicle, car or bus or bike or cycle, whatever it may be, so what kind of motion it is, think. Obviously that will be non-uniform motion with non-uniform acceleration. So because we'll have to apply brake, traffic will come, we'll have to take turn, all these things are involved in what? Non-uniform accelerated motions. So with all these basics, I will divide this motion into different categories and what all formulas can be applied there in order to approach the problems. Okay, so we are studying in this chapter only translational motion. What is translational motion? The moving like this, moving like this kind of motion. This is translational motion. Now there is what? Circular motion is there, rotational motion is there. So we don't touch that part here. Okay, we are studying only translational motion. So translational motion we will divide into different. Translational motion. So first thing is motion with the constant velocity. Okay, with the constant velocity. With the constant velocity. So here the formula which we have used is displacement by time, or delta x by delta t. Now we have, this is constant velocity, this is, again we have two more types. One is with the uniform acceleration, another is with the non-uniform acceleration. This is uniform acceleration. Okay, and this is non-uniform acceleration. Non-uniform acceleration. Okay, now here the formulas are clear. Whenever acceleration is there, see v is equal to s by t. In this formula, acceleration is not present. In this formula, acceleration is not at all present. So this formula cannot be used here. V is equal to s by t. We can't use this formula here. So here we use equations of kinematics. Equations of kinematics. 4 equations are there. Okay, v is equal to u plus at, v square is equal to u square plus 2as, s is equal to ut plus half at square, sn is equal to u plus a into n minus half. Each equation we will do problems and analyze it. Okay, so v is equal to u plus at. V is, see, acceleration is there, so definitely velocity will change. Initially there will be some other velocity. When the particle reaches here, velocity will be different, either less or more. Okay, so initial velocity will be there, final velocity will be there. U is initial velocity. Okay, u is initial velocity. This is final v and this is initial velocity. This is acceleration and this is the time of journey. Time of journey. Okay, see, all the particles starts from 0. Correct or what? All the particles start from 0. Okay, not down. All the particles start from 0. So as a standard, every time we will have to take u is equal to 0? No. So from the initial class itself, we are discussing about the observer. Some observer will start observing from some point of time and he will stop observing at some point of time. So all the discussion will be based on some observer. Okay, that will not be mentioned, but logically we should understand that. Okay, someone is observing, based on that observation only every discussion is. Say for example, if someone says initial velocity is 10 meter per second, it means that it is not like he is not starting from 0. He must have started from 0. But the person who is observing, he started observing that that point of time initial velocity is 10 meter per second. So we will take like that. And definitely this person is going to stop the vehicle somewhere. So always we should be 0, but it is not like that. The observer will be observing at some point of time. Velocity will be 25 meter per second and he stopped observing. So that is what the final velocity is. So v is final velocity, u is initial velocity, a is acceleration, t is time of the journey or total observation time. Okay, this is first equation. Second equation, v square is equal to u square plus 2as. Same way, final velocity, initial velocity square, acceleration, this is displacement, total displacement of the journey. I mean how much the observer is observing, that much. Okay, third one I am writing here, no problem. Third one is s is equal to ut plus half at square. Displacement, initial velocity into time of journey, acceleration, time of journey square. 4, Sn is equal to u plus a into n minus half. This equation can be written in this way also, u plus a into 2n minus 1 divided by 2. This way also we can write the equation. Now here there is some difference for the equation. First you note it down, then I will explain that equation alone. So a body started from here, or if it is coming like this, but we started observing from here. We are considering only this much distance. This is s, displacement. Body may continue after that or it may stop here. We don't care. Okay. So this is the thing which we are considering. So this total displacement is what is s. Suppose another case, it is coming like that, we have considered like this. For the first second, so total time maybe this is 5 seconds, this is 5 meter or 10 meter, whatever it may be. For the first second, the vehicle moved for a distance of 5 meter. So S1 is 5 meter. Second second means not 2 seconds, it is just second, that is first second 5 meter, totally 3, if there are 3 seconds are there, then first second, second second, third second. We are taking the displacement for 1 second separately, first displacement, second displacement, third displacement, likewise. So this is the displacement for the first 1 second, this is the displacement for the second 1 second, then later if this is 15 meter, this is third. Likewise we can have up to nth second. So nth second has a displacement Sn. So likewise if we put n is equal to 1, we will get the displacement of the first 1 second. If we put 2 here, we will get the displacement of the second second. So when we do problems, we will get good clarity. Okay, not this example also. Okay, right. So uniform acceleration, the case with the uniform acceleration, it's equations, everything is clear. So this is constant velocity v is equal to s by t or delta x by delta t, right? Now here v is equal to u plus at, v square is equal to u square plus 2as, s is equal to ut plus half at square, then Sn is equal to u plus a into n minus half. So 1, 2, 3, 4 equations. So if acceleration is uniform, single value of acceleration, then we can use this. If no acceleration, we can use this. Here also if the acceleration is 0, v is equal to u. If this acceleration is 0, v is equal to u, that is constant velocity. If this acceleration is 0, v is equal to u. Same way, if this acceleration is 0, this entire term will become 0 and s is equal to ut. Same is this. S is equal to t. S is equal to v into t. Same thing. If you apply the concept, everything is same. But so here no acceleration, here acceleration is there. Third case, Non-uniform acceleration. Non-uniform acceleration means you will have lot of values of acceleration. In the first 1 second, acceleration could be 5 meter per second square. Next second maybe -1, then 2, maybe 3, -4. It varies. So if we are in a position, if we want to use this equation, then which acceleration value we will put here? So if non-uniform acceleration, these formulas can't be used. These formulas can't be used. Okay. So here what we do is calculus. What is calculus? Calculus is a powerful mathematical tool. So since this is +1, so calculus is a powerful mathematical tool. Now we are in +1. So calculus we will study in detail in +2. Okay, +2. Differentiation, integration, certain process are there, but we need that tool here, mathematical tool here. So before starting this topic, we will have a mathematical session. I will be discussing differentiation, integration, all those things. That just necessary formulas for physics we will discuss there. Okay, but this is just an ocean. Those who are preparing for JEE will get lot of questions from that part alone. Calculus is like some 4 to 5 chapters in +2. Full entire topic is calculus. Okay, but we need only certain parts. So that thing we will study before we get into this. Okay, so this is how the motion is divided. Okay, I summarize the types of motion. One is constant velocity. Okay, uniform velocity. We move with the uniform velocity. V is equal to S by T, or V is equal to delta X by delta T. Bus, nothing else. Okay, no acceleration there. Acceleration is 0. Another thing is velocity is increasing uniformly. 5 meter per second, 10 meter per second, 15 meter per second, like that. So we have one value of acceleration there. It is called uniform acceleration. Uniform acceleration. So for that we use these equations of kinematics. Okay, then whenever the acceleration is changing, we get lot of values of accelerations. Then we cannot use all these equations. There we go with the differentiation and integration. Okay, so among these 3 types of motion, okay, 1, 2, 3, only this motion is constant velocity motion, or we can say uniform motion. This is, we can say, uniform motion. Remaining all are non-uniform motion. Here all velocity is changing. Only, very clear, understand this very clearly, only acceleration is uniform. Only acceleration is uniform. Velocity is not uniform at all. Velocity is changing here. Okay, so only this is, we can say, uniform motion or motion with the constant velocity. Remaining all are non-uniform motion. Only difference here it is, this is uniform acceleration, that is non-uniform acceleration. Okay, so pause the screen. If you want something to note down, note down. So we will do some problems from the second part. First part already we have done problems. Second part, here we will do some problems. So direct problems, that questions that can be asked in board exams, I will just tell one example. Then we will do some good standard problems that we used to get in NEET and JEE. So if we do problems in NEET and JEE, definitely we will be in a position to do board exam problem. Board exam problems we will feel like it is very easy, dead easy. So just I will tell you, say for example, just I am making a question now, just fabricating a question now itself. Okay, so Q. Okay, someone is saying like a body is moving with initial velocity 5 meter per second. Okay, and acceleration is there. So acceleration is 2 meter per second square. If the, what will be the velocity? What will be the velocity after 10 seconds? What will be the velocity after 10 seconds? These kind of simple questions can be asked. Okay, so here here T is there, U is there, V is there, A is there. So best equation we can use is V is equal to U plus AT. Okay, so what we need to find? Velocity after 10 seconds. So initially is given like 5 plus acceleration is there 10. We need to find after 10 seconds. So that's it. So this is 25. So 25 meter per second. So if something is coming with a uniform velocity, it is coming with velocity 5 meter per second, need not be uniform. It was 0, then it was increasing or maybe decreasing, whatever it may be. But initial velocity is given as U is equal to 5 meter per second. Acceleration is given at 2 meter per second square. Likewise, we can substitute and get the answer. Okay, so this is a simple problem. Okay, so now we will do a problem with a little bit. We need to think. Okay, we need to apply our brain. Okay, so take that question. Okay, a bus is starting from rest. A bus starts from rest. A bus starts from rest with acceleration 5 meter per second square. Okay, a car crosses the bus with velocity 25 meter per second. Okay, at what distance the bus will overtake the car if they move in straight line. If they move in straight line. So option A 350 meter, option B 400 meter, option C 250 meter, option D 300 meter. Okay, so question is, a bus starts from rest with the acceleration 5 meter per second square. A car crosses the bus with the velocity 25 meter per second. Okay, at what distance the bus will overtake the car if they move in straight line? These are the options. Okay, so what happens? See, bus was at rest, then bus is about to move. It is about to move. That time a car passes the bus at a 25 meter per second velocity. Okay, now the question is, at what distance? If they are moving in straight line, the distance and displacement both are same. If they move in straight line, at what distance the bus will overtake the car? That is a question. Okay, noted down the question. We will do. So bus, initially it was at rest, so its initial velocity is u is equal to 0 and acceleration is given as 5 meter per second. Now when it is about to start, when it is about to move, car crosses, so car has got uniform velocity. Car has got uniform velocity which is nothing but 25 meter per second. These are the data. So bus is moving with the uniform acceleration but non-uniform motion. Bus is moving with the uniform acceleration, or we can say non-uniform motion but uniform acceleration. So here, but car is moving with the uniform motion or constant velocity. Velocity is 25 meter per second. Okay, it is very clear. Now at what distance this will overtake the bus will overtake the car? How bus will overtake? Even though it starts from 0, it's starting from rest, it has got acceleration, so velocity will increase. This is moving into constant velocity, so definitely this can overtake the car. So when it overtakes, suppose bus is starting from here, if the car is crossing at this point, from here the story starts. So bus is moving, car is already ahead. At some point, say for example, suppose if this is the displacement or distance at which the bus overtakes the car, then we can say both of them. Suppose if here this is the line or this is the distance at which bus overtakes the car, we can say the distance traveled by bus is equal to distance traveled by car. Both will have to travel same distance, then only we can say this will overtake. Clear or what? Understood the logic? That is the crux here. Now what we will do? One equation for car equation, we can say velocity of car into time is equal to, for this the displacement is nothing but ut bus ut plus half at square. So this is nothing but the displacement of car or distance of car. This is nothing but displacement of bus. S is equal to V into T. Here S is equal to ut plus half at square, the formula which we have seen. Okay, so this will be equal. Now u is equal to 0, this term will become 0. This term will become 0. So what we are getting? Velocity of car is 25 into T is equal to half acceleration of bus is 5 into T square. So this T, this will be cancelled, 5, 25 will be cancelled, this is going to be 5. So time taken for overtaking is, if this T2 goes this side, this will become 10 seconds. Time for overtaking is 10 seconds. The time is same na, for both. Okay, so now you can put in this equation or this equation, whichever equation. If you put 10, we will get displacement. So we will put what? In car, the displacement of car and displacement of bus both are same, is equal to velocity of car is 25. If we put that 10, we will get what? 250 meter. So that is the answer. If we use the equation of bus, that also we can use S is equal to ut plus half at square. So displacement of bus, both are same, distance of car, distance of bus, is equal to ut. U is 0, so that will become 0. Half at square, half into the acceleration of car into T square, we got 10. Okay, so this is 100, 2 and 100 cancel. What will happen? What we get here? 50. 50 into 5 is 250. So either we can use this equation or this equation, whichever be the easy equation, choose that equation, put the value and get the answer. Okay, not pause the screen and not the answer. Hope it is clear for you. Okay, see, this is a good question, reasonably good question. If you are getting the answer easily, if you understood, then well and good. If you feel difficulty, if you feel fear, okay, no need to have any fear. By doing good questions, I swear you, one day you will say that this is an easy question. Okay, these kind of questions will be easy, but all depends on the practice done by us. Okay, we will have to do practice. Okay, you will have to take similar problems, apply, think, struggle, get the answer. So your logic level will improve. Okay, clear? Okay, so now basically how many types of motions are there and what are all the basic physical quantities or physical terminologies or basic concepts which we need to study, that 5 words that we have done. Types of motion also we have done. Now we have got into the chapter. we have got into the chapter. Certain few more things I will say, then we'll wind up for today's session. From next session we will do some more problems putting all these equations together, then we will go to the different topics of this chapter. Okay, so see, velocity, what is its unit? Meter per second. What is its dimension formula? LT raised to -1. What about acceleration? If distance or displacement, it is meter, it is L. Okay, clear or what? This one. Okay, same way acceleration, meter per second square. So acceleration is nothing but delta V by delta T. So meter per second, so we get what? Meter per second square. Or otherwise, if what is the dimension formula of velocity? LT raised to -1. Divide by T is also there. So this will become LT raised to -2. Okay, so LT raised to -2. And acceleration is also a vector. Acceleration is also a vector because acceleration is velocity by time or change in velocity by time. This is actually vector. So acceleration is also a vector. Acceleration is also a vector. Suppose if this is a path, someone is running in which direction? Okay, we'll just assume that this guy is running in that direction. Okay, I'm not that good in drawing. So if he is running in this direction, the direction of displacement is also that direction. Direction of velocity, that is also that direction. If acceleration is there, change in velocity, what will be the direction of acceleration? See, velocity is equal to S by T. So this velocity will follow the direction of this displacement, and acceleration is equal to delta V by delta T. So will this acceleration follow the direction of velocity? Velocity's direction is this. No, never. The reason for acceleration is, force. If you are running with a constant velocity, if I run behind you and if I apply a force, then your velocity will increase. Just you will get a jerk, right? That is nothing but increase in velocity. Just for a moment a jerk will be there, you may fall down. But when I apply force, your velocity will increase. Or if I apply force in this direction, holding your collar and pulling you back, then your velocity will come down. That is acceleration is there. So if the force is applying in the direction of motion, acceleration will be positive. We can say acceleration follows the same direction of displacement velocity, no problem. If I am pulling you back, then acceleration will be negative. Velocity will come down. So the direction of acceleration doesn't have any connection with the direction of velocity. Acceleration follows the direction of force. Okay, the reason for acceleration is force. If force is there, acceleration is there. If force is not there, acceleration is not there. Regarding force, you will study in the chapter laws of motion in detail. Okay, now we are not going into much discussion, just mentioning. Okay, so just I am telling this one sentence with the regarding force. Remaining all the things we will study later. So acceleration follows the direction of force. Okay, acceleration follows the direction of force. Clear? So we'll wind up today. So keep on revising the topic, keep on doing new questions, then only you will be able to understand the lesson, okay, in a much effective way. Okay, don't hesitate to ask doubts and clear the things. Okay, thank you, goodbye, good luck.